Hey everyone, welcome back to day 47 of Coding Every Day. Today I'll be looking at these greedy problems, and let's just do the next one in the list, gas station. So I have not read this before, so let's get started. There are n gas stations along a circular route. You are given two integer arrays, gas and cost, where gas of I is the amount at I, and cost of I is the amount of gas needed to travel from the ith station to the I+1 station. Okay, so like to continue one index forward, it cost of I gas. And it's a circle. Okay. You have a car that can store an unlimited amount of gas, but you begin the journey with an empty tank at one of the gas stations. Empty tank. Return the starting gas station's index such that you can travel around the circuit once in the clockwise direction. Okay, if it's impossible, return -1. So we have to return, okay, and it's guaranteed that at most. Okay, so it could be 0 or 1 solutions. We need to return the starting index. All right, let's look at the test cases here. So here, I'm going to draw this out. 1, 2, 3, 4 is gas. 1, 2, 3, 4, and then we have cost. I don't know why the color doesn't matter. All right, and then cost, which will equal 2, 2, 4, 1. Okay, and let's just make that look like a 2. All right, does not that much better. All right, 2, 2, 4, 1. Okay, so the solution is 3. So that's the index so this is the only place we can start such that we can complete the circuit. So if we start at index 3, the gas is what? The amount of gas. Okay, we fill up with 4 units of gas. So our gas tank is at 4. Okay, and then it cost 1 to go to the next. So then we go here and we fill up okay, so then this cost 2. So then we're at 3. So okay. So our position, we start here. We start here with a tank of 4, and then this is the cost. So it costs us 1 to go here, right? Travel to station 0. Do we not fill up at every stop? We must fill up at every stop. Okay, so we travel to station 0. Okay, yeah, I see. So this cost, so it's our current tank minus this cost plus this amount of gas. I said that in reverse. No, I said that correctly. So then our tank would be, after one move, it would be 4. So it's your tank minus like the current cost plus gas at I+1, basically. Like the gas we'll get at the next station. Yeah, and if we ever, so we just keep going until we either, so our 2 stop conditions are if we get 0 gas, not necessarily. So if the cost is greater than our current number of gas, like in our tank, then we have to stop. Or if we've traveled length of gas times. Okay. So then here it costs 2. So We move over and then we refill 2. Then it cost 4, or no, it cost 2 again. So then we go over here and get 3 back. And then it cost 4. Okay, so at this point, our current gas is 4. So it cost 4. So it cost 4 to go here, and then do we refill 4? Yeah, plus 4. So plus 1, plus 2, plus 3, plus 4. So it's kind of like, yeah, I see the pattern. So it's basically that. Okay, and then let's just walk through this example. So we have gas of 1, 2, 3, and cost of 2, 3, 2. Okay, and in this case, there's nowhere to start. Okay, so for instance, I think the naive approach to this would be try every single index. Try every single index and see if you can complete the problem. And if the first one that you encounter which you can complete the problem, you would return that. So that would be n squared. So I'm guessing, so that's the sort of brute force way. I'm guessing we can use some greedy idea to reduce this to probably linear, maybe n log n, but probably linear because that's more common. Okay. All right, so we can't start here because our tank is only 1. Well, okay, let's say we did start here. So our tank is 1, and then our cost is greater than our tank. So that means starting here fails. Okay, if we look here, same thing. So our tank is 2, and then our cost is 3, so we fail. Then we look at 3. So here our tank is 3, and then it costs 2, so then we move back here with a tank of 1. Refill 1, and then we get 2 minus 2. So our tank when we arrive here is 0. So then we fill up 2, and then our tank is 2 at this position, but it cost us 3. So we fail. Right, so we're stuck at station 1. So 0 plus 3 minus 2 plus 1 minus 2. Okay. So let me just see that. So 0, so that's how much we start with, and then we fill up with this 3 here. And then it costs us this 2, right? So it costs us that 2. And then we fill up 1. And then it costs us 2, right? Minus 2. So that says this is 0, which looking at it, this evaluates to 1 plus 1 minus 2. Yep, okay, so that is 0. So in my initial going through it, I stopped here because I said 2 minus 3 is -1, but here it just stops when we get 0. So it cost us 2. I feel like it shouldn't stop there, right? Because what if, like, let's say we had 1, 4 like this. And if we started here, so everything will be the same. It'll be 3 minus 2, this 2, plus 1 minus 2, and this will be 0. But this 2 got us to this one, and then we would do plus 4 minus 3 equals 1. So my understanding of the problem is that this should return true. This should return true. Okay. So I could definitely code up the n squared solution. So what is greedy about this problem? We want to maximize our tank. So I noticed in this, it just starts with the one that has the biggest. So, okay, so the total cost of the circuit never changes. What I mean by that is like, no matter where you start, to complete the circuit, you'll always have to pay the sum of cost. The only problem is you need at every step to have more in your tank than cost of I. So to me, it would make sense to try to maximize your starting gas. Your starting gas. So do you just pick the highest, or do you pick the one with the highest difference? Because here, so if we just did a linear scan on where to start. So here, for instance, if we did, so if we said like 4i in range, I'm just kind of gonna sketch this out. I don't intend for this to be part of the solution. So if we say for range of gas, and let's say we had like diff, and we called that gas of I minus cost of I. So I'm noticing for I equals 0, in the first test case, it will be -1, which means we definitely cannot start here. We will fail right away. For I equals 1, it's 0, which means you won't fail right away, with my understanding. Okay, and then I equals 2 is 3 minus 4, which is -1, so you definitely can't start there. And then I equals 3 is 4 minus 1, which is 3. So would we just pick the max of these, like whichever starts you with the most gas? Is there any way that would fail? So now I'm going to try to think of a test case or some logic that would make that idea fail. Okay, so let's say we had a cost of 1 and gas of 3. When would we not want to start here? Okay. What if this, so we would go to the next station with 2. So what if it costed 3 and we got 0 gas? Is that a thing? Can we get 0 gas? Yeah. Okay. So so this is a system where if you start here, you will fail. So now can I make it where if you start somewhere else, you can succeed? For instance, what if you have, so the difference here is 2. So what if you have 2, 1, 2, 1, 2, 1, 2, 1, like this? Okay, so if you start here, you will if you start here, your tank will be 2, and by the time you arrive here, you get +1 essentially, and then here you get another +1, and here you get another +1. So it would be 0 plus 2 minus 1 plus 2 minus 1 plus 2 minus 1 plus 2 minus 1, which is 4. Yep, so that would be 4. And then, so you'd have tank equals 4 at this point. Then you would subtract, or did we already subtract the 1? Yeah, 1, 1, 1, 1. Okay, so we'd arrive here with tank equals 4. And then we would get 7 minus 1 equals 6. And then we would get 6 minus 3 equals 3, and then we would be fine. Okay, but another stipulation of the problem is that there has to exist only one solution. So with this problem, we need only how much do we need here? We need to arrive at this point with how much? So we had, we arrived there with 4. So we said what we arrived with plus 3 minus 1 has to be greater than or equal to 3. So that's x plus 2 has to be greater than or equal to 3. So that means x has to be 1. So we have to arrive here with 1. So what about just this solution then? So if we start here, which has the maximum difference as I described here, diff of 2. So in yellow here, I'll do diff. So here it would be 1, 2, and negative 3. So if we just picked the maximum one here, we would actually fail. Because we wouldn't have enough. But because this gets us the extra gas. Okay, so this kind of reminds me of the problem where you pick the maximum sum subarray, in the sense that here always nets us positive gas. So we'd want to start like basically we need to overcome negative 3. So I think you can simplify the problem in terms of just these numbers, to be honest. And so it becomes you want to build up the biggest sum that you can in the problem. So for instance, let's look at this example here. So what I mean by that is you would find the maximum subarray and start at the beginning index of that point. So if we look at this example, it's hard to engineer a case that only has one possible solution though. Okay, 1, 2, 3, 4. And if this works for this example, I may just start coding that and just learn that way. Okay, and then 2, 2, 4, 1. Okay, so now we'll calculate the diffs here, which remember is just gas of I minus cost of I. So it will be negative 1 here, 0 here. This will be negative 1, and this will be 3. So the maximum subarray, the subarray here with the highest sum is just here. And then we pick the starting index of that. Okay, so let's call, I'll say diffs is like that. And then we will diffs dot append this. Okay, so if I okay, so now what I want to do is iterate through. Maybe I could call this like net gas. Okay, so net gas is how much gas we gain at that position. Okay, so what we're going to say is we're going to iterate through, so I'll say for I in range length of net gas. So this is sort of like the max, so find subarray with max sum. Okay, so we're going to start I here. So we'll have current sum. So it'll start as 0. And then we'll say, like gas from this station. Well, that would just be diff, right? Is net gas of I. So we don't need that to be a variable. So we'll say total plus equals this. So total is going to be equal this, and then if, all right, then we need a J pointer as well. Let's say while I is less than Okay, so my idea is we'll have I, and then when this is, so we'll have total. We'll have total. So total will start as 0. We're going to start here. Total is going to be total plus equals diff, which is net gas of I. And then if it's negative, so if total is less than 0, then we should reset it to 0. So then when we get here, it's 0, and then we'll say like max found is negative float infinity. If total, I guess we could say max found is equal to max of itself and total. Maybe not, because we want the index. So if total is greater than max found, then max found equals total, and we'll just say max index equals I. Okay, so I don't know if this makes sense. So if we get negative, then we'll reset, and basically we'll just find the biggest sum possible. But we want to remember the starting point of that. So whenever this resets, we could just say like, so this is a bit clumsy. I could optimize this later. So whenever we reset, the starting point equals I, right? Well, it should be I plus 1. Okay, let me just print. Let me just print some debugging stuff here. So we'll have I, and we'll have total. And then here I'll print at the end max found. What is I? I does not start at 0. That makes sense. Okay. So I equals 0. In the total, I think I want this underneath here. So just putting these print statements here to help debug it. Okay, so when I is 0, our total is negative 1. So we'll reset. And then when I is 1, and let me just print max updated to, and then that's not, I need an F. Okay. All right, so here we start at 0. We see our cost is negative 1. So we reset, and now the starting of a new streak will be at I equals 1. Okay, I equals 1, total equals 0, so we update our max. So max means that's the biggest sum we found so far is 0. And then I is, so max I will still be, max I will still be that. Okay. Let me try just feeding in, this example isn't that great, so let me try, I'll keep that one up there. let's say we have 3, -1, 2, 5, -6, -3. So I'm going to just hard code that in here. So we'll say net gas equals 3, -1, 2, 5, -6, -3, like this. Okay. So it finds, so what am I printing at the end? Max found. So it's saying that 9 is the max. So here is 7 plus 3. And then, okay, so what's the max I want to see. Max I is 3. 0, 1, 2, 3. Yeah, so we need... Yeah, so we're going to need to know where we started our max. So we can't have this. So we need to have J go up. Okay, so what we're going to do is have I here and J here. And then we'll say, okay, total is 3. Total is -2. Sorry, +2. Total is 4. Total is 9. Total is 3. Total is 0. Okay, what if we had something... I want to see if it still gets it right. What if this was -10 right here? So I'm going to change this to -10. And I'm going to comment that out and say I. And I want to see if it gets it. So the correct answer should be 7. Okay, 3 and 7. Okay, so it looks like that's working. So, how are we doing on time? 27 minutes. Okay, not terrible. I am slowing down a bit though. So okay, so I should keep going until total is negative. In which case, okay, so we'll have J go up by 1 every time. So J equals 0. Okay, so we'll have J go up by 1 every time. Muted myself for a second there. All right, J is plus equal 1. All right, so we're going to add J to the total. And then we're going to say if total is less than 0, if total is less than 0, we want to set I equal to J plus 1. So in this case, here total is -7. So we want I to move here and J to move here. And then J will go up by 1 anyway. So I will set here and then J will naturally go up anyway from this increment. Okay, if it's less than 0, we also want total to reset itself to 0 at this point. So now it's 0. Whenever we find a new max, so if total is greater than max found, what we want to do is we want to store I because that's the start of the max. So we'll say max index like this. So if total is greater than max found, we'll say max found equals total. Max index equals I. And then we don't need this. All right, so let's... max I should give me the start now. Max I is not defined. Max index. Okay, so now it's giving me 2, 0, 1, 2, and the sum is 7. All right, great. Now let me make this -1 and see here. Now it should give me 9 and 0, 0, 9. Okay. So now what I'm hypothesizing is this is the max gas that we can get. So I want to just return. I don't actually even have to do. Okay, there is a small problem though, and that's that it's circular. So what I'm going to do is return for now just the max index, and then I suspect, so I should fail on the first test case because the first test case uses the okay, I failed on both of them. Yeah, I'm not handling cases. Okay, this doesn't mean that it's wrong for the general case. However, we don't want J to stop here, actually. When do we want J to stop? So we want J to move length of gas times. So we could say count equals length of net gas. And we want to say while it's less than count, and then count will go up every single time. So instead we want to run it this many times, regardless. So for instance, count will start at maybe we should say actually while count is less than length of net gas. So count is going to run okay, so count is going to run n times, and here J will be equal to J plus 1 mod length of net gas, and I will be equal to this mod length of net gas. So this will keep it circular, right? Another option, so this doesn't actually work, I don't think. Yeah, this doesn't work. It's a good idea, but I would need modifications. I think there's an easier thing to do, actually. So I'm just going to put it back to how it was. Okay, so J is going to start at 0. So instead, I'm going to have net gas. So I want to extend net gas. So I'm going to say net gas equals itself plus net gas up until the last index. So I'm just going to extend it like this. Okay, so the last index here is -3. So then I'm just wrapping it around, and then I want to calculate do I just want to loop through this and find the max total? So in this case, let me print max index and max found. So it says 0, and that has 9. And also I could print zero has a cost of 9. What if I made it so the wraparound was the most important. So if net gas was, let's say, the first example, so it would be -1, 0, -1, 3. So in this case, what if this was +1? So it should give me 4. Yeah. Okay. And then it tells me what? It tells me it starts at index 0. That's true. Okay, so the wraparound is getting me here. So that's true. It does, like, right here. Wait, is that true? Shouldn't it be here? Oh, well, I guess... Alright, let's make this -10. Okay, so now it is identifying correctly index 3. Okay, let me try just returning max index here. So my idea is now the wraparound is simulated by so now you, like, no matter which position you're at, you're still going to iterate like length time, like n times. Like, so here you're looking at the subarray or the max. But what if you have, what if net gas is like 1, 2, 3, 4? Well, in this case, it doesn't actually matter. There has to be exactly one solution. Okay, how do I know if there's no solution? Let's just get rid of that for now. So how do I know if there's no solution? So if the max, so that gets us the starting point. So in this case, could I just take the sum of the differences? No, right? Let's look at the sum of differences in the other one. So here it does seem possible, because if we start with 3, maybe I could just try that. So if the sum of net gas is less than 0, return -1. And I'm thinking that may mean it's not possible. Okay, now this is... Let's only go up until... length of gas. Alright, let's see if we get any errors here. Okay, that does work. Okay. That looks weird. Okay, so let me clean up the solution and then think about it. And then I guess we could say net gas equals gas of I minus cost of I for I in range length of gas, like that. We don't need total. Okay, and this is definitely linear because j goes up by 1 every time and never goes backwards. This part is linear, and then this is linear as well. So that's exciting. So how it works, I kind of just intuited the extending part and it made sense. But let me try to dissect it a little further. Well, basically the thing is you need to know the max. Like if this is the subarray, so if the subarray with the max sum starts at this index, you want that one. But if you just end the array here, then you're limiting the potential of this index as a starting point because it can only have itself. So I just extended it so that way you can have it like this. So that's a way to deal with these wraparound problems. Another way that I tried was you could use mod, but that seemed a little bit more confusing than doing it this way. And to determine if it's not possible, so if the sum of the diff basically, so if the original net gas before I extend it, maybe I could just say like no, it's fine. You could just have a variable instead of doing this thing here, just say the sum of that old one. Doesn't really matter. Okay, so with that, I saw that the first, like this one, you start at 3 gas, and I know it's possible because you don't use all of it, or you use all of it. You don't use more than you have. But here you use 2 and you only have 1. And because this is telling us the net gas at every point, that's all we need to determine the information. So we take the sum of the net gas. Okay, so let me try this solution on LeetCode because sometimes, and what was it called? Gas station. So sometimes on LeetCode it will accept it even if it does not on LeetCode. So let's submit it here. See if it works. Okay, it works, but it's very slow. Interesting. What if I do this? Does that fix it? Do you not even have to loop through it? Or is it just because because this is linear. This part is for sure linear. This part, I'm adding 2 lists together, and I'm also splicing this list off the bottom. I mean, I don't think that will make a big deal either. You could do it that way. No, you can't. You can't pop like that. This will be the return value. Yeah. So you'd say netgas.pop. This isn't gonna make a difference. Yeah, it's quite slow. It is linear though. It is for sure linear. What are the constraints of this problem? 10 to the 4. So instead of infinity, if I do that, negative. Oh, well. So this is tricky. I think you might actually need infinity because you could have just a bunch of negatives. Like if you have 0 for every gas and you have negative, or no, if you have 0 for every gas and 10 to the negative 4 for every I don't know, but that shouldn't matter. And J, so J starts at 0 and every time it goes up and we never touch J. Sum is also O of n. Let me see how many milliseconds. So here is like 6 and mine is, really? It might just be like this stuff that's taken all the time. Yeah, I don't know, guys. So in my opinion, I would say this is O of n. I would say it's O of n. Unless I'm missing something. I would say this is O of n. So either way, that's the solution for today. I'll look at the solution and see if there was a faster way or if I just did it really inefficient. But yeah, I'm glad I was able to get this one. Today was day 47, I believe, and it's about to be 47 minutes in the recording. Thank you guys all for watching. Glad I could get the linear. Like I said, maybe it looks like I might have done something wrong. But anyway, yep, thanks for watching.